All right, let's look at the example of a non-homogeneous equation here. All right, so part A, we want to find the complementary solution. All right, so let's do that. All right, so we just turn it into a characteristic equation. So it's r squared plus 4 is equal to 0. All right, so you can see that this is going to be simply r is equal to plus or minus 2i. Right? So the complementary solution is going to look like y sub c is equal to, so this is going to be just a c1 cosine of 2x plus c2 sine of 2x. Right? So we found that. All right, then let's do part B. All right, part B is to find the particular solution, y sub p. All right, so let's do that. So I'm going to use the method of undetermined coefficients. All right, so we look at the right hand side is 2x. All right, so we know that the form of the solution is going to contain x, and also a derivative is a constant term. So you would have either a constant term or an x term. So it's going to be a linear function. So y sub p is equal to, I would say, ax plus b. Right? Something like that. Right, then we have to look for the overlap, but in this case, complementary function is a linear combination of cosine of sine of 2x. So there's no overlap, so we don't have to multiply by a power of x. So ax plus b is the form. All right, but we would have to find the a value and b value. To do that, we just have to look at the derivative. So you have y sub p prime is going to be simply a, right? And y sub p double prime is going to be equal to 0, right? So all we have to do is plug those things into the original equation, see what kind of condition we can get. All right, so y double prime is actually 0 plus 4 times y. Y is actually just ax plus b, right? And which has to be equal to 2x. So this is equal to 2x. So let's simplify that. So you can see that you have 4. Actually, let's see. What's the easiest way? I'm going to just distribute the 4. So you have a 4ax plus 4b, and which is equal to 2x. Right? So from there, we can actually get a couple of conditions. Right? So the coefficient of x is 2 on the right hand side, and the coefficient of x is 4a, so we have to match that. 4a is equal to 2, right? So we can simply divide through by 4 to get the a value. So 2 divided by 4 is 1/2. And here, constant term on the left is 4b, and the constant term on the right is 0. So b is going to divide through by 4. B is equal to 0. Alright, so therefore, we have a complete formula for the particular solution. Y sub p is equal to 1/2 x. Alright, so we got these solutions. Let's see, I'm going to just box them in. So this is our complementary solution, right? And this is our particular solution, right? And what we want to do is we want to find a solution to this initial value problem. So we have to find a solution that satisfies the differential equation and also these two initial value conditions. right? So let's do part C. And basically, we want to find the solution. So find the solution y for the initial value problem. Right, so let's do that. So any solution can be written this way. So y is equal to just the sum of complementary solution and the particular solution, right? So which comes out to be, since we already know what they are, so complementary solution is C1 cosine of 2x plus C2 sine of 2x. And the particular solution is 1/2 x. Right? So what we can do is we can find the C1 and the C2 using these given initial value conditions. Right? So let's do that. Alright, first let's plug in x equals 0. So y sub 0 is equal to, alright, cosine 0 is 1, so you have a C1. And sine of 0 is 0, and 1/2 times 0 is 0, so it's just C1. So this is have to be equal to 1. So we already know what C1 is. Alright, then let's take the derivative. So y prime is equal to, right, derivative of C1 cosine of 2x would be negative 2 C1 sine of 2x. And derivative of C2 sine of 2x would be 2 times C2 cosine of 2x. And derivative of 1/2 x is going to be just 1/2. Alright, then we plug in x equals 0. So y prime of 0 is equal to, right, sine of 0 is 0, so cosine of 0 is 1. So you have a 2c2, and then you have plus 1/2. And this is going to be equal to 2. Right? So first, I'm going to just subtract 1/2 from both sides. You have a 2c2 is equal to 2 minus 1/2 would be 3/2. Right? Then I'm going to just divide through by 2 to get the C2 value is 3/4. Alright, so therefore we actually have a complete solution. So the solution of the initial value problem is going to be C1 came out to be 1, so you have a cosine of 2x. And the C2 came out to be 3/4. And the sine of 2x. And the particular solution is 1/2 x. Alright, so this is the solution of the initial value problem. Alright, that's it. I hope that this was clear.